Right now, we treat AI like a hyper-fast typing assistant. We write out our app ideas in a prompt or a planning document, hit enter, and the AI spits back a wall of code. But that text is static. It sits there, waiting for us to actually do something with it. You still have to manually copy and paste those blocks of code into your editor. You have to figure out exactly where they fit, stitch the files together, and track down the missing dependencies or package conflicts that inevitably pop up. Then you have to spin up a local development server, configure your environment variables, and pray it compiles. The momentum you gain from the AI generating the code grinds to a halt the second you try to test it. Curious, these current AI tools are co-pilots. They require you to keep your hands on the wheel, constantly supervising every line, every file transfer, and every terminal command. We haven't had a true autopilot system. So while the typing process is fast, the actual timeline to ship a working feature hasn't accelerated at the same pace. The human developer remains the primary bottleneck. That brings us to Google Jules. Jules is an autonomous engineering agent. It is designed to execute software engineering tasks directly within your environment. It doesn't rely on a back-and-forth chat interface. You assign it a task, and it runs entirely in the background while you move on to other work. By moving the AI out of the chat box and into an asynchronous workflow, the developer is removed from the mechanical execution loop. Instead of pasting prompts into a browser window, you can pipe a raw text file, like your project's to-do list, or a specific GitHub issue directly into the Jules command line interface. This diagram shows how the system routes that request. Jules takes your text file and immediately clones your entire target repository into an isolated, secure Google Cloud virtual machine. Inside that virtual environment, the agent analyzes your existing architecture, figures out how the pieces connect, and writes the necessary code to build your new feature, like adding new routing logic for a web application. Before it ever shows you the result, Jules spins up the application inside the virtual machine. It runs your automated testing frameworks, validates the logic, and even checks the user interface changes. Once the tests pass, it packages all of those verified code changes into a clean pull request, sending it back to your origin repository for you to review. What started as a static bullet point in a text file has been processed through an isolated cloud pipeline and returned as a fully tested, ready-to-merge codebase. You didn't write a single line of code. At this stage, the only action required from you is to review the code and click Merge to push the changes to a live production environment. But pushing to production is where software usually breaks. You merge the code, the build starts on your server, and it suddenly crashes because of a missing dependency or an incorrectly configured environment variable. Here is a diagram showing how Jules handles that exact scenario. The system continuously streams the server deployment logs directly back into the AI agent's diagnostic feed in real time. If an error occurs during the build, Jules reads the log, diagnoses the specific failure, writes a patch to fix the configuration, and initiates a redeployment. It does this automatically. This creates a self-healing deployment loop. It bridges the gap between testing code locally and keeping a live production server stable without human oversight. For an independent developer or a solo founder, this requires a different way of working. You stop writing boilerplate code and start managing a fleet of AI engineers. You take on the front-of-house responsibilities. Your time goes toward defining the architectural direction, designing the user experience, and refining the core business logic. Jules handles the back-of-house work. You can schedule the agent to run nightly test coverage passes, refactor messy files, or execute site-wide SEO audits while you are offline. By enforcing this strict division of labor, a single developer can maintain the testing, refactoring, and deployment cycles that usually require a broader engineering team. We started by looking at how ideas get trapped in text documents. With an autonomous pipeline, those planning files are no longer static wish lists. Your everyday project management notes and workflow outlines have become direct executable commands that trigger real engineering work. Solo software founders now have access to a level of rigorous testing, maintenance, and continuous deployment pipelines that used to require dedicated DevOps teams. The operational gap between typing out an idea and running an auto-healing production application is now a matter of background execution.